Okay, turn to page 331. This is section 3.5. And we're going to do some stuff with linear equations. I know they're linear because if you look, they have a constant rate. This one's charging $3.65 per gallon, $3.85. And remember, your slope is your rate. The only difference is this one has an extra one-time fee. So basically, if you buy the car wash, you're going to get cheaper gas. If you don't, you pay more expensive. So I could have y equals, my rate is always my slope, so $3.65. And you could use G here for gallons if you wanted to. So if instead of X, if you wanted to call that G, you could. So you could do like cost equals $3.65 per gallon plus the $5.50 for the car wash. And the cost is $3.85 per gallon and then no extra cost. Otherwise, you can use X and Y. You just have to remember what they stand for. So your car wash is your one-time fee. And your gas is your ongoing fee. And again, if you want to use G here, you're more than welcome to. And so I want to know when they're going to break even. So a couple ways of doing that is one is to set them equal to each other. Because if the cost here equals a cost here, then we know we're breaking even. And so we have the cheaper gas per gallon with the car wash. We know when it equals the more expensive gas. All right, so again, I have adding in here, so I need to order about backwards, so I'm going to have to do add and subtract first. And notice I only have numbers on this side. This is my only just standalone number. The other ones are both x's. So I want to get all my x's to this side. So I need to get rid of this. And so to get rid of that, I'm going to subtract 3.65x to both sides. And then I'm going to subtract 3.65x to both sides. So really what I'm doing is I'm looking at how do my rates differ. So if I subtract, there's a 20-cent difference per rate, which you can see if you read. And so what I'm trying to figure out is when does that 20-cent difference in slope or in rate pay for the car wash, basically. So when, after how many gallons does the car wash break even or it kind of pays for itself? So again, there's no adding or subtracting left, so now I'm ready to divide. And so when I divide, I end up getting 27.5 gallons. And again, that's where if you use G, it might be easier to keep track of that it stands for gallons. So if like this was a G and a G and a G, and let's see where else, G and G, then at the end I'd be like, oh, that's gallons, right? But if you do X, just keep track of it. So what does that mean? So that's my break-even point. So at 27.5 gallons, it does not matter which route I take. I can do either or. It won't matter. Now, what if I do less? Well, this is how many gallons the car wash is basically a wash. So if I have less gallons, I'm going to want to do this guy. I'm just going to want to pay more per gallon. But if I do more than 27.5 gallons, then suddenly the car wash is free and I'm benefiting from the cheaper gas. So the break-even point is where it doesn't matter, where one is equal to the other. If I only buy 1 gallon of gas, obviously this is going to be a lot cheaper, paying more per gallon because I'm not paying for the car wash. So less than 27.5, this is a better deal. More than 27.5, this is another deal, or a better deal. And we're going to do this with Excel so you can kind of see how to find the break-even point on a graph, which we will need to know how to do for class. So let me get out of there. Yes. And then let me, it's hard to see here. Get out of that and get out of that. Okay, so I'm going to get into Excel. Let's full schedule. I'm not sure. Oh, there it is over there. All right, we'll just open a new one. Okay, and so what do we have going on here? So we have gallons of gas. So let me see if I can hook this up to my keyboard here, make life easier. Okay, so gallons. And then we have what? With the car wash. So with car wash. And then no car wash. And again, I can come up here and make these go apart a little bit. Okay, so gallons of gas, you always want to start in 0 because real life always starts at 0. So, and I'm just going to go by ones here. Now the nice thing is we got the answer first, so I kind of know what I'm looking for, which is always kind of helpful. Because otherwise I might stop. Oops, I screwed up there. I might stop before I hit the break-even point, and so I'm having troubles here. 17, 18, 19, 20, 21, 22, 23, maybe 23, 24, 25, 26, 27, 28, 29, and I'm going to go a little bit past our break-even point. All right, so with the car wash, so you're going to click on the first cell, and then remember the formula is up here where it says function. That's like y equals. So I'm going to come here. The thing people forget is to start with an equal sign. And so what was it? The gas was 365. Asterisk is for times, and it's per gallon. So you have to look at where's your first gallon amount, and that's an A2. Plus, we paid, what was it, $5.50 for the car wash, I think? Right, and then remember you can grab this little corner guy, or you can copy and paste. I'm just going to try to grab it if I can. I might have to grab my wireless mouse if I'm having some issues here. And it should fill in the numbers, all right? And you can always check like $30 times the gas, add in the car wash, make sure it works. All right, and then no car wash, click where you want your first answer, come up here to the formula, start with an equal sign, and that was, what was that? Was that $3.85? Yeah. So $3.85 per gallon, so that's your slope. So it has to be times the variable, which in this case is what, A2 again, is that first variable. So I'm going to hit enter, which if I don't buy anything, I have no fees because it's not like I had to buy a car wash or anything. And then there's those prices. All right, and again, I might want to move that over a little bit. Now the nice thing is we did the algebra first, so I knew the answer. All right, now I'm going to highlight all these. And I'm going to insert, and I want a scatter plot. So scatter, and you can do one with dots or just lines or whatever is fine. All right, and let's see, I can make this bigger, and then I could change the title. So let me highlight this. So car wash versus no car wash, and then I could say something like price comparison or something along those lines. And then again, if you want to click over here, you could add axes titles. All right, so then I could change this to, what is this? The input is what, gallons? And then I could come over here and change this one to, what is that, price or money. So I could just put a $sign there. All right, oopsie, maybe. Try again. Shift. Does that make, no, that's not liking my shift there. This one's always harder because it's sideways. Here we go. Shift, $sign. There we go. Okay. All right. And so here's my graph. All right. And so it's kind of hard to see because, you know, we didn't go out super far. But it crosses, you can see it's going to cross about that 27.5. Now, if I keep going on my chart, you can kind of see where one's cheaper and one's more expensive. So if I go 31, I'm going to have to redo my graph. But 32, 33, 34... and then I could redo my graph and it's going to show more of where one's lower. But it's going to cross at that 27.5, which is about right in there somewhere. Notice the orange is cheaper to begin with. See how the cost is lower? So that's no car wash. So not getting the car wash is cheaper until I hit that 27.5. And then the blue one's more expensive at first. But then if I keep going, if I make my graph go out further, the blue is going to be underneath down here. And so with the car wash is actually going to be cheaper in the long run. But you have to get 27.5 gallons of gas. Now on the chart, I could put 27.5, but another way to tell is if you look right in here, Let's see if I can highlight that. All right, if you look at between 27 and 28, you can see this one's more expensive and this one's cheaper. So, but notice how it flip-flops at 28 gallons. This is cheaper and that's more expensive. So that's how I can tell that there's a break-even point in between there, because at 27 gallons, this option's more expensive, this option's cheaper, but as soon as I go to 28 gallons of gas, it flip-flops. This one's cheaper, that's more expensive. So it had to cross somewhere in there. And then on the graph, I could see it crosses at 27.5, and then with the algebra, I know that's the same answer as well. All right, go back to the bottom of page 334 and try to answer question number 2. So look at question 2, A through C, and then I will pick up there. Okay, so to finish up that last one, I forgot to talk about what happens when you sub in the break-even point. So our break-even point, this is half of it. This is the X value. This is your input. So when you buy this many gallons of gas, what does that mean on the Y side? So go ahead and input this into that formula and input that, and just again do order of operations. So take this times 27.5 plus the 5.5, enter, and you should get that amount, and then do the same thing here. So type this times that, and you should get the same amount. All right, and that's your output. So, and since it's money, I'm going to round to the nearest penny, so about, what, 88 cents. So what that means is, if you buy this many gallons of gas, no matter which option you choose, you're going to pay $105.88. So at the break-even point, this is how many gallons of gas you buy to break even, but this is how much money you spend when you break even. All right, if you haven't done number 2 yet, go ahead and pause, answer A, B, and C, and then I'll come right back. Okay, so let's look at this situation. The thing we have going on here is what's your independent variable and what's your dependent. So usually time is your independent variable, like a chemistry experiment. You mix it together and you see what happens over time. But this is like you're making objects. So the thing you have control over is how many boxes you make, and what you don't have control over really is how much time it takes. So if you make 0 boxes, how much time does it take 1 box, 2, and so forth. So this is your independent variable and dependent, or this is your input, output, or X and Y. So let's write our 2 equations here. So time is the output, and so the one gal, Dina, Emily can pack a box in 6 minutes. All right, so Emily can do it 6 minutes per box. 0 boxes, 0 time, 1 box, 6 minutes. Her sister, Dina, is a little faster, but she comes late. So she can do 4 minutes per box, but she shows up 20 minutes late. So obviously the one gal's making boxes while the other one's not even there. All right, so what is the break-even point? Okay, so let's look at that. So we have 6B. So when does her work equal up with her work? Again, you have variables, you have adding, but you have variables on both sides, but you only have a number on one side. So we're going to bring the B's to one side. So 2B equals 20. To get rid of multiplying U, divide. So boxes equals 10. So at 10 boxes, they break even. Now, if I shove that in, put 10 in for boxes up here, you're going to get 60 minutes. And if you put 10 in here, you're going to get 40 plus 20, which is also 60 minutes. So 60 minutes is your output. So what your break-even point means is when they both make 10 boxes, then the time for both of them would be 60 minutes. Because the one's faster, so she's basically made up her 20 minutes of being late. All right, and when you subtract, you can kind of see that when does that 2-box difference, or what is it, 2-minute difference per box, the rate, because the one's slower than the other, so when does that catch up to the 20 minutes? And it's at 10 boxes. All right, and if you look at page 335, they graph that, so I'm going to stop and we'll look there real quick. Okay, so if you look at this graph, you can see the break-even point right there. So at 10 boxes, and then you can see at 60 minutes, they break even. And so what that means is she's more efficient at first, but then the sister that came late is more